Now we've gotten the following functions, the first, the second, and the third, alright? Okay, great. Now to find the range of the first function, we want to look at f of x equals 3x minus 2. So this is the function, so to find the range of this function, we need to find the inverse of the function first, and then look at the domain of the inverse of this function. Great. Now to find the inverse of a certain function, we need to first of all replace f of x with y, right? So just by replacing the notation, so that means in this place of f of x, we are going to have to replace that with y, and then we are going to have just y is 3x minus 2. Right. The next thing is to interchange x and y, right? So in place of x, you put y, in place of y, you're just going to have to put x. So that gives us that y will be interchange x and y. So we're going to have that x is 3y minus 2, right? Okay, great. Then the next thing we'll do here is to solve the equation for y. So after interchanging x and y just by replacing y with x and then replacing x with y, that is just by interchanging, we are not making x subject of formula. So the next thing is to solve the equation for y. This is where we will try to make y to stand alone on one side of the equation. And that will be by, first of all, adding 2 to both sides and dividing both sides by 3. So to get y to stand alone, we need to add 2 to both sides. That gives us x plus 2 will be 3y, right? So that's just by moving 2 to the left-hand side. And then we divide both sides by 3. That tells us that y is x plus 2 divided by 3. Great. Now the fourth point tells us that the new y is called the inverse of the original function. So after making y subject of formula, then this new y is called f inverse of x, right? Given that the function was denoted by f of x. So we can notice that f inverse of x, which is the new y, is x plus 2, then divided by 3. Alright, good. So what we have to do here is to find the domain of the inverse of that given function. So after finding the inverse of the function, we need to find the domain of that inverse, right? And that will give us the range of the original function. So since this is the inverse of that, just by the notation f inverse of x, then the domain of this function will be the set of all numbers that will make this function to be defined, right? Good. So to find the domain of a certain function, we need to look at all possible inputs that will make the value of the function to be a real number. Great. Since we are talking about real valued functions in this course. So which kind of number will we put in that function that will make the function not to be a real number? Well, a function is going to be undefined in the state of real numbers if the denominator is 0. That is in the case of rational functions like this. Or if you are having a square root function or a function with some radical terms, then if the input is going to be a negative number, then that function will be undefined in the set of real numbers. So we neglect a negative input under a square root sign, and we also neglect 0 in the denominator. But looking at this function, there is no radical sign, like something like square root, fourth root. So, and in the denominator, we are only having 3, and there is no way that 3 in the denominator will be equal to 0. So we see that that function is defined for all real numbers, right? Great. So the domain of that inverse is going to be the domain of that inverse, which is actually the range of that function, domain of f inverse of x, which is the same thing as the range of f of x, is going to be the set. Okay, let me put it down here. It's going to be a set containing all real numbers, alright? Containing all real numbers such that x, okay, that's all. Alright, maybe let me make the notation a little bit better. You can say it's containing all real numbers x such that x is in R. So what this tells us is that the range of this function will be element called x such that the elements are members of the real numbers. So this notation, this R here with the double bar shows the set of all real number. That is every possible number you can ever think of. Right, great. Okay, that's better. Now let's go back to the second question.